All right, we have a rational expression here with a denominator that is not a rational number. That's why we beat you to death with fractions. And there's a lot of math in them. So we need to rationalize the denominator. So what we have to do is multiply the denominator by a number that's going to get rid of all those radical signs. Let's get some working room here. And we're going to use that perfect squares trick. We're going to multiply this parentheses, what's in the parentheses here, times it's what we call the conjugate. A conjugate is, by definition, basically it has the same numbers in there but different alternate signs. So if this is a plus, this is going to be a minus. If this is a minus, that's going to be a plus. But you'll notice first term's the same, first term the same, second term's the same, second term the same. What happens when you multiply them is the middle terms are going to drop, they're going to cancel each other out. And it's going to leave you with the first term squared minus the second term squared. And before we do that, whatever we multiply on the bottom of a fraction, we have to use the same amount multiplied on the top, okay? This right here is actually just 1. So we're not really changing anything multiplying wise. But now let's go ahead and do the math. So let me show you that again. The middle terms are going to cancel out, so we're going to get negative 10 squared minus, square root of 10 squared minus square root of 6 squared. And these exponents are going to do away with these radical symbols. It just comes to be 10 minus 6, which is 4. So that is the denominator, but now let's clean up the numerator a little bit. We could leave it in this form, I guess. 5 times the square root of 10 minus square root of 6. But I'm going to go ahead and multiply this out just to clean it up a little bit. And that is your answer. MGZ out.